Okay, so match each feature with the situation with the corresponding statement. So first of all, let's look at A, because I know this notation's a little weird. Well, what is A saying? It's saying, look at the X's, and we're going to be in between 4 and 7. So everybody see how I read that one? Okay, so X is in between 4 and 7. So when X is in between 4 and 7, what's going on there? It's decreasing, it's going down, right? Everybody see where that's happening? So you should have matched 3 with A. All right, what about C? What y'all put for C? Increase. So from 1.5 to 4, what's happening here? We're increasing. Everybody see it? Okay. All right, what about B? What is this one talking about? Range, because what's the lowest point? 2. What's the highest point? 16. And then the last part, 0 to 7. What does that describe? The what? Y-intercept. So sorry, it went 0, 7. Why is it not the domain? Let me take all this mess off so you can actually see it. Why is this not describing the domain? What's the domain? All the X values. Do the X values go past 7? Well, it keeps going on, right? Okay, and that's a point. So 0, 7 would be right there. Cool? Questions over that? You got to know these terms. These don't go away. Okay. So today we're going to talk about the parent functions. So last week we kind of like went over all of these different functions, or we talked about the first 3, and then we're going to talk about the other 3 in just a second. So on your paper, you should have this graph. And again, I'm sorry that it's a little spotty. But we're going to talk about the domain, the range, the intervals of increase, intervals of decrease for all of these characteristics, okay? For all of these different parent functions. So the domain for a linear function is always forever going to be from negative infinity to positive infinity. What this means is that there's an arrow on the end, and it continues on forever in the left direction, and it continues on forever in the right direction. That's all this is saying. It's saying from left to right. Range is also going to be the exact same thing. It's going to be from negative infinity to positive infinity. This is from bottom to top. So from bottom to top, where does it stop and start? Well, negative infinity to positive infinity. Now, if we were getting on a roller coaster and we were writing this graph, are we increasing? Are we decreasing? Increasing. And when are we increasing for? Like, does it ever come down? No. Okay, so there's no intervals of decrease. And it increases the entire time. So we're going to say from negative infinity to positive infinity. Okay, so we should be pretty comfortable with the domain, range, intervals of increase and decrease. Now, interval of positive values. This always trips people up. Right here is the x-axis. If you are a positive value, you are above the x-axis. If you are a negative value, you are below the x-axis. So when does this happen? Well, it happens from 0 to positive infinity. And when does the negative happen? That's negative infinity to 0. So this next one is kind of like a new graph, but you've seen it before, I think in like 7th grade. Okay. This is called an absolute value parent function. Okay, so we got that y equal, or g of x equals the absolute value of x. Absolute values make things positive. So if it's negative, it makes it positive. If it's positive, it stays positive. That's why there's no numbers below the x-axis. Are we going to have any negative values here? No. So we can go ahead and put none. Now for domain, you see how these arrows go off into the different directions? It's going to be from negative infinity to positive infinity. So from left to right, it's going to go negative infinity to positive infinity. Now my range is bottom to top. So what's my lowest y value? 0. So what's my highest y value? Well, it keeps continuing up, right? So infinity. Are there any questions about how I got domain or range? Okay. Now, intervals of increase. So if I'm at Six Flags and I get on this ride, am I going down or up? Down. But where is that happening? Well, it's happening from negative infinity to 0. And then am I going up or down? Up. I'm going from 0 to positive infinity. Now, we already said that we're not going to have any negative values, but we're positive the entire time. So that's going to be from negative infinity to positive infinity. Okay, so I gave you this worksheet, and it's analyzing characteristics of parent functions. But what I would like for you to do is complete this kind of with a partner. So I want you to work together. Okay, now there are, I'll open this. Oh, JK. There we go. Now there are a couple of answers that may have more than one answer. So that's something to keep in mind when you're answering these questions. But they're using these 6 equations to answer these questions down at the bottom. So we're going to do number 1 together, though. All right, so it says my function does not have a domain of negative infinity to positive infinity. So is there any graph that doesn't go from left to right? Okay, which one? Square root. Any other ones? Nope, the square root. So I'm going to write square root. And does everybody see where I got that from? Okay. Now, what is the domain of the square root function? Where does it start? What's the leftmost x value? 0. And how far to the right does it go? Infinity. It keeps going on forever, right? We okay on that one? Okay. So your job is to work 2. You're going to do 2 through 7. Okay. All right. Cool. I'm going to give you let's start with 15 minutes and then kind of check in where we're at. Okay. So you're working with a partner and you're completing 2 through 7. If you want to split it up, like you take the odds, I'll take the evens, that's fine too. Okay. Over, what'd you get? Okay. So we did 1 together. So what'd you get for number 2? Absolute value. And what'd you get for the other function? Quadratic. And for interval of increase and decrease, you got something like this. And decrease is same thing. And this, boom. Yeah. Are there any questions about how I got that? So absolute value is that V shape, and then quadratic is that parabola. So remember, it goes down and then it goes back up. You're telling me when that happened. That's from negative infinity to 0, and then from 0 to positive infinity. So that's how I got those things. Okay. Now, what'd you get for number 3? Linear and cube root. Okay, and interval of negative values. You got something like negative infinity to 0, and then positive was 0 to positive infinity. And same thing for the other one. Any questions over that? Okay. Go and flip the page. Let's look at number 4. All right, so number 4, 5, and 6. Let's talk about those. So what'd you get for 4? What is a range that's greater than or equal to 0? I know one of them is quadratic. One of them is absolute value. And the last one is exponential. You're right. Okay. Now for range, what you want to do is you want to look at the graph and you want to go, okay, my range is greater than 0. So it has to be above the x-axis. Okay. All right. Number 5, I have a y-intercept that is not 0, 0. Exponential. And what is that y-intercept?
1.
So 0, 1. Okay. All right, 6 and 7 are a little tricky. You actually haven't used this verbiage in a while. The constant rate. Constant rate is the same thing as saying slope. Okay. So the only one with a constant rate that doesn't change is a linear function. And the slope of that linear function is 1. The reason why is because we have y equals x. What number is out front in front of that x? A 1. On the last one, we have f of 2 equals 2. We've talked about function notation. So really we're saying, hey, the point 2, 2 is on this graph. So which graph has a point at 2, 2? There's a question mark on the end of that. Hold on. So looking at our graph, do we have 2, 2 for square root? No. Do we have 2, 2 for cube root? No. Absolute value? Yes. And linear. So absolute value and linear. Okay. On your other mastery check this week, okay, what will happen is you'll be given a function and then it'll ask for the key features, or it'll describe the key features and it'll say which one has these things. Okay, so same thing that you're seeing right here. Any questions about that? Pretty comfy? We're good? Okay. So I want to take just a moment and practice this just a little bit. I want you to take out your laptop. Have you ever played GimKit before? Okay, I got yes and no. Okay, great. Why? Why does that one not belong? Okay, that's fair. Anybody else come up with another one for another reason? No, everybody's good with that one? Okay. So when we do the which one doesn't belong, there is no wrong answer. You just have to have a justification for it, okay? You could have been like, this one, because it's not curvy, because it has two straight lines. You could have came up with anything. Okay, so we're going to talk about in behavior. In behavior and intervals of increase and decrease are similar, but they're different. So which function is this one? What's the name of that one? Absolute value. Good. Okay, so this one's called absolute value. Now, when we're dealing with in behavior, it's where does the graph end up? So looking at this arrow right here and right here, where is the graph going when it goes to the left? It's going up, right? Which is infinity, right? Okay, so as we move left, as we go left, we go up. Now, as we move to the right, what's happening? We go up. So as we go right, we go up, right? Now, mathematicians be trifling sometimes, and they like to use their own notation. So what I just said in words, we're going to write out in a notation. So this first one right here, so it's going to be x approaches negative infinity, y approaches positive infinity. Okay, so the little arrow means approaches. Okay, so as we move to the left, we're going up. Now let's do the other side. We have x approaches positive infinity. So as we go to the right, my y values also go up. What we just wrote in words is the exact same thing as that notation. For my people who are like more visual learners, remember our x is on this x-axis. My negative infinity is over here. Positive infinity is over here. For my y, this is my y-axis. Positive infinity is up here. Negative infinity is down here. So when we say as we move to the left, we go up, that's what it's talking about. As we move to the right, we go up. Okay on that? Okay, again, that notation sometimes trips people up. Now let's talk about interval of increase. Where does that happen? Interval of increase. So again, imagine yourself on the little thing. It's going down, this is going up. So where does that happen? 0 to what? 0 to positive infinity, right? When does it have positive values? Is there ever a time where it has negative values? Is it ever below the x-axis? No. So the entire time, which is negative infinity to positive infinity. One really important thing with characteristics, do you notice how I'm asking myself questions? Is the exact same thing that you need to be doing. You need to be saying, when does this happen? Okay. So make sure that you're listening to the questions so that you can ask yourself those same things. Okay, go ahead and look at the next slide. And what I want you to do is write out in words what's going on for the in behavior. So as you go to the left, is it going to positive infinity or negative infinity? As you go to the right, is it going to positive infinity or negative infinity? Okay, take a moment, write the words. So as we go to the left, what's happening to our y values? Where are they going? They're going down. As we move to the right, where is it going? Okay, so now let's put that in the notation. Okay, so that's going to be as x approaches negative infinity. Let's start with the left first. My y is approaching negative infinity. As we approach positive infinity, my y is approaching positive infinity. Are there any questions about that? Now, what is our domain for this one? What are our x values? Negative infinity to positive infinity. When you do domain, remember you have a start and a stop, or you have a left and a right, however you want to think about it. Okay, so that's going to be from negative infinity to positive infinity. What about negative values? Is there anything that's below the x-axis? Where? Negative infinity to 0.
2 plus 2 plus 2 plus 4 plus 3 plus 4 plus 3 plus 2 plus 3.
I think that's it. 2, 2, 2, 4, 3, 4, 2, 3.
Yeah.
Yeah.
I'm missing another 3.
Another 3. Okay. So this would be 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. 9 plus 4 is 13. 13 plus 3 is 16. Then 20. And 2 plus 3, 25. Okay. So then when you multiply that together, what'd you get?
6,912.
6,912. Okay, anybody beat that one? No? There is a number that's bigger than that. Yeah. Nobody got higher than 6,912? So why'd you break it down like this?
Well, I started with like 3 like big numbers, and I guess like I kept decreasing them, bringing them down, and like realized that I kept like turning a bigger numbers. So
Okay. Yeah, bigger numbers don't always mean multiplication is going to be bigger too. You could have done numbers like, there it is, 3, 3, 3, 3, 3, 3, 3, 2, 2. And that gave you 8,748. Yeah, so you're on the right track. Right thought process, almost there though. Okay. All right. So tomorrow you're gonna have a mastery check. Okay, so you're gonna have a mastery check. Those are little quizzes. Okay. Now remember, these do get replaced by your test. So if you bomb it, yes, your test is kind of like redemption, but you're gonna have a mastery check over parent functions and specifically domain and range. Okay, so those 6 parent functions that you had, you need to make sure that you understand the domain and range for it. Okay,